So this is video number 3, and this is about Avogadro's relationship, which we referred to in the second video, but I wanted to make sure that we understood. So Avogadro's relationship, and you can write this down in your notes if you want to, that relates moles, which are used in chemical equations, to grams. Now, there's a third part that indicates Avogadro's number. That's why we call it Avogadro's relationship. And that's the actual amount of atoms and molecules that are there, but it's too big to count. And so we don't really use it. You may be asked just, from a mathematical standpoint to put it down on a problem sometime, but it's not anything that we'll use in the lab or anything that's really meaningful when you talk about a chemical equation. You're usually only talking about moles and grams. So there are 3 different ways the relationship goes: elements, covalent compounds, and ionic compounds. Now, let's see here. I'm going to use carbon as my element. And so 1 mole of carbon. And then I'm going to use, for my covalent compound, let's use water, 1 mole of H2O, okay. And then for my ionic compound, I'm going to use table salt. They always use table salt. And the reason I'm using it is the one that I have memorized. I know what it is, so I don't have to stop the video and look it up. Okay, so you'll see that the beginning for all of these are the same. It's always going to be 1 mole in the relationship. And when you're doing a ratio, your ratio should only ever have 1 mole in it. Now, you might have a certain amount of moles out to the left of the problem, but in the ratio, in that top and bottom ratio, like I showed you in that last video, there should only be 1 mole. Okay, and then the next part is Avogadro's number is always the same, except for elements, it's going to be atoms. For covalent compounds, it's going to be molecules. And for ionic compounds, it's going to be formula units. Okay? And so what you'll notice is the first and third part of these relationships are going to be the same. 1 mole, 1 mole, 1 mole, Avogadro's number, Avogadro's number, Avogadro's number. And then in the middle, you have the molar mass. And so for 18.02 grams, that is 58.442 grams. And that is 12.01 grams. And so the middle number is really the only one that's different. And the reason why it's different is we look it up from the periodic table, and all of these elements have different masses. So carbon is easy. You don't have to do any adding. It's just 12.01, and you can look up that its mass is 12.01 from the periodic table. Now the 18.02, if you add up the hydrogen twice, because there's H2O, so you need 2 hydrogen, 1 oxygen, add it up, 18.02 grams. And then 1 mole of salt, 58.442 grams. Boom. Right there. So that would be 1 sodium and 1 chloride. So that's Avogadro's relationship, and you can make this for any element, covalent compound, or ionic compound, and that pretty much covers everything we're dealing with. Talk to you later. Bye.